morning students. Today we will discuss about definite integration, and one of the important concept is nothing but definite integration as a limit of the sum. This point is very useful in board examination, only practical purpose. In board examination, only practical purpose. But some question they will be asked at the time of JEE examination also. That's why it is very important. JEE as well as practical examination. Okay, this is one of the basic concept of definite integration. What is the definite integration? Integration of a to b f of x dx is nothing but area bounded by the curve. This curve y equal to f of x. This curve and the ordinates x is equal to a to x is equal to b and x axis. Means only first positive area we consider, not necessarily in negative. Means fourth quadrant, area lies in only first quadrant. Okay, means area bounded means in between curve, this ordinate, these two lines, curve and x-axis, means this portion is essential. That is the meaning of integration of a to b f of x dx. Meaning of the definite integration is nothing but area bounded by this curve, these two ordinate and x-axis, isn't it? Suppose this area split up number of small trips. Here start from a, x is equal to a, that is nothing but x naught, x1, that is nothing but x1 is nothing but a plus h, this initial value plus h, x2 a plus 2h, up to xr a plus rh. Similarly, last is xn, that is nothing but b, and b is nothing but a plus nh. Equal interval, number of sub intervals are there, and split out this total area in small trips. Small strips. Okay. Then if trips is very suppose xn equal to b, then you can write down b is nothing but n is nothing but b minus a divided by h, and as n tends to infinity, then h tends to 0, or if h tends to 0, automatically n tends to infinity. Okay, consider small trip, very small trip, means very close, 2 points. The region P R S Q P, that is the meaning of integration of a to b f of x dx, is nothing but total area you can divide small sub intervals, and that is nothing but area between, first of all area between, try to understand, I am explaining here, ABLC, this first area. Then second area is like this, ABD and C, ABDCA, and third area is nothing but area of ABDMA. Okay, what is the relation between these three areas? This is smaller as compared to this, and this is smaller as compared to this. Means suppose you can consider small trip means only this area is less than area under the curve is less than area under the bigger rectangle. This is smaller rectangle, curve, bigger rectangle. Therefore, our required area lies between these two rectangles, smaller rectangle as well as bigger rectangle. I have written here the region this divided in sub intervals. Now area of the rectangle ABLC is less than this, this is number 1. Then as this difference is very small, means h is very small, automatically the area is denoted by Sn. If this difference is very small, automatically these three areas are very close and all areas are equal. Therefore, small Sn is nothing but h times. What is the area of this rectangle? Area of this rectangle is length into breadth. Length means h and breadth means f of x naught. F of x naught breadth and length means h. Total area is h into this product of length and breadth. Similarly, product of length and breadth. Here also length and breadth. But number of strips are there. That's why I written h. I am taken common. F of x naught plus f of x1 up to f of xn means total area is h into summation of f of xr. R goes from 0 to n minus 1. I am considering initial value because small rectangle. Initial value to less than last value xn minus 1. Okay. This is required area. Then you can think about a bigger rectangle denoted by capital Sn is equal to h. Capital. What is the difference between this? Difference between means h is nothing but this. This width is nothing but h, and this is y is nothing but f of x naught up to like this. Length into breadth. Okay. Similarly, h common. F of x1, f of x2 up to f of xn, that is nothing but h times summation of f of xr. R goes from 1 to n. As n tends to infinity, all areas of equation 1s are equal. Therefore, limit of, I have taken limit because n tends to infinity, not exactly infinity. Therefore, area of this region is the same as area of required region is the same as area of bigger rectangle also. And this is denoted by the new concept limit x n tends to infinity. You can denote this area integration of a to b f of x dx. Okay, and how to write this area is nothing but limit h tends to 0, h into bracket, all these things. Sn I have written here. Okay. Then what is meaning of the h? H is nothing but, suppose last value xn is nothing but b, and which is equal to a plus nh. Then transfer the c in this side, b minus a, divide h, you will get value of n. N is nothing but b minus a divided by h. Replace the value of h by b minus a and divide by h. Divide by h written in terms of limit into 1 upon h, and all these things are as it is. F of xa means first value, f of a plus h, and so on last value. Okay, means limit of sum is nothing but, only remember this formula carefully. Last formula is very important. Other things are for understanding purpose. If width is very small, automatically curve is also very small, therefore difference is very small. That's why smaller rectangle and larger rectangle is near about equal to curve. Therefore this area is nothing but, as per this formula, integration of a to b f of x dx is nothing but b minus a limit 1 upon h as n tends to infinity. Here you can write n tends to infinity. Here you can write h tends to infinity, because I am replacing value of h, and value of h means b minus a divided by n. Therefore here you can write n only. Here you can write n as n tends to infinity, and simplify. This is the important formula for finding area under the curve, that is called as definite integration as the limit of sum. Any doubt, guys? This very important concept, theory part is there, but it is very useful for JEE examination as well as at the time of state board. Only practical purpose this point is important. Okay, it is enough today. Stop here.